We're looking at special segments and triangles now. So the first thing is a blank is the point on the segment exactly halfway between the endpoints of the segment. So this is one of our vocabulary words from the first unit. Right in the middle of a segment is called the midpoint. Oh, okay, so if M is the midpoint of line segment AB, over here on the picture, then we can say that segment AM is congruent to segment MB. And similarly, that means that we can say that the distance from AM is equal to the distance from M to B. So a blank is any segment or line or plane that intersects a segment at its midpoint. So that would be a segment bisector. So for example, on this picture here, what would be a bisector of line segment AB? Well, if P is the midpoint, and it is because they show us that these two segments are congruent, then line PQ would be our bisector. So I'll say line PQ. Our next one is a perpendicular bisector. So if a bisector is also perpendicular to the segment, it is called a perpendicular bisector. And so on the picture that we have over here for line segment JK, I see that line RS does intersect JK at its midpoint, because they tell me that the JR and RK are congruent. And it is perpendicular, I can tell, because they give me the little square that lets me know that this is a 90-degree angle. So I could say that line RS is a perpendicular bisector of line segment JK. So that brings us to a theorem. So our perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So any point on this line, this perpendicular bisector here, would be equidistant from A as it is from B. So they tell us here if line CD is a perpendicular bisector of line segment AB, then that would mean that these two segments over here are equal. They are from A to C is the same distance as it is from C to B. So if I wanted to mark that on my picture, I could put 2 ticks on that because they're not the same as this line segment down here, but they are congruent to one another. Okay, so we can use the perpendicular bisector theorem to find these missing measurements here. So we're going to find each measure, and this is a place where you need to pause the video and try these 3 problems, and then come back and see how you did. All right, so on the first one, I marked on the picture here that these 2 line segments had to be congruent to one another because the line XC is the perpendicular bisector of line segment WY. So if this side over here is 12, then that means XW is also 12. On this one over here, they did not tell me that these 2 segments are congruent directly, but they did show me that this was a perpendicular bisector by telling me that this point B is equidistant from A as it is from C. And they showed me that this was perpendicular. So that means that this segment over here and this segment over here are congruent, and they wanted the distance from A to C. So that would be 7 and another 7, so that means 14. On the third one over here, they want the length of LP over here. So I've got my line segment PM, They do show me that line segment LN is a perpendicular bisector of that. They show me these two line segments here are congruent, and they do intersect at a 90-degree angle here. So that means these two line segments on the edges are congruent. And so to solve this one, I would set those two line segment measurements equal to one another, and then use a little algebra to solve for x. This didn't ask me for x though, this asked me for the length of LP. So once I got my x value, I had to take the expression that they gave me for LP and substitute in that value and then solve it. Okay, for our next concept, change colors. All right, so it says, and blank divides an angle into two congruent angles. It can be a line, a segment, or a ray. And so if you've got something that divides an angle into two congruent angles, then that would be an angle bisector. And that was one of our vocab words from Unit 1 or Unit 2, somewhere in there. Okay, so now if ray BD is the angle bisector of angle ABC, then that would mean that angle ABD is congruent to angle DBC. And that also means that the measure of angle ABD would be equal to the measure of angle DBC. All right, so that brings us to another theorem now, the angle bisector theorem. It says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if we have an angle bisector here, and we've got a point that's on it, then the shortest distance to each of the two sides is going to be congruent. So this and this would have to be congruent according to this theorem. So it says if BF bisects angle DBE and FD is perpendicular to BD, so FD perpendicular to BD, and FE is perpendicular to BE, then we can say that these two line segments are equal distance. So I could say from D to F would be equal to, wow, that is an awful D. There we go. From D to F would be equal to from the distance from F to E. All right, we can also use the angle bisector theorem to find missing measurements. So here we go. We've got CP is what we're looking for here. Actually, this would be a good place to pause the video again and try these three and see how you did, and then come back and I'll explain a little bit. Okay, welcome back. So on this first one, we can tell that BP is is an angle bisector for angle ABC. They tell me that these two angles are congruent here. The arc is not really well drawn there. They should have separated them a little bit so that you can see that they're two separate arcs. But anyhow, because of that, that means point P is equidistant from one side of the angle as it is from the other. So that would mean if AP is 8, then CP is also 8. Those two line segments are congruent. And the second one there, the measure of angle WYZ. WYZ is the one we're looking for here. And looking at the picture, they tell me that this point W is equidistant from X as it is from Z, so from each side of the angle. So that means that this is an angle bisector, which means these two angles in here are congruent. And so if this one over here is 23 degrees, then that means this one that we're looking for, WYZ, is also 23 degrees. On the last one, we're looking for the length of line segment QM, or the distance from Q to M. And again, this is not well drawn here. These arcs should have been separated a little bit so that you could see that they were telling you that these two angles are congruent to one another. But anyway, so because this is an angle bisector, that means that point Q is equidistant from the left side of the angle as it is from the right side of the angle. So that means these two line segments QM and QP are congruent, and so their measurements are equal to one another. And so to solve this one, we'd start by setting up those measurements equal to one another, do a little bit of algebra to solve. We got 5 for x, but it was not asking for x, it was asking for the length of QM. So then I would go back and get the information about what QM is and substitute in my x value, and I got 12 for that length.